Welcome back to the Python programming series. In our last module, we tackled loops, how to automatically repeat actions using for and while loops. But today, we're moving into an absolutely crucial concept that forms the foundation of how we handle data in Python. We're talking about lists and tuples. If you've ever wondered how on earth programs manage thousands or even millions of pieces of data efficiently without totally crashing, well, you're in the exact right place.
But before we get into the code, let's set the stage a bit. Python is just kind of built differently. As its creator, Guido van Rossum once noted, he was a massive fan of the comedy group Monty Python. He thought naming programming languages after acronyms or famous people was just boring. So as a tiny act of rebellion, he went with pop culture. Python was designed from day one to be highly readable, accessible, and frankly, fun to use. And the data structures we're looking at today embody that exact same philosophy.
Which brings us to The Zen of Python, written by Tim Peters back in 1999. Two of its core principles state, simple is better than complex. Flat is better than nested. Python strongly favors readability over rigid complexity. The data structures we're learning today exist to make your code beautifully simple and highly efficient. They take messy data and organize it elegantly, almost like a massive, perfectly labeled filing cabinet.
Okay, let's dive right in. Here is our roadmap for today. First, Python sequences. Second, creating lists. Third, modifying lists. Fourth, the power of tuples. Fifth, real-world applications. And finally, a mini challenge.
Number 1, Python sequences and the problem with variables.
To really appreciate why we need lists, I want you to imagine you need to store 5 student names. Without lists, you'd have to create a separate variable for every single one. Student 1 equals A, student 2 equals B, and so on. Now imagine doing that for 50,000 students. Creating one variable per value is messy, it's highly inefficient, and it is very un-Pythonic. We desperately need a unified container. And here's our solution, directly from the Python language reference. A list is defined as a mutable sequence of arbitrary Python objects, formed by placing a comma-separated list of expressions inside square brackets. In plain English, a list is simply a single container variable that holds multiple items in a specific order. So instead of 50,000 separate variables, you literally just have one list called students. Number 2, creating and accessing lists. Now that we know why they're essential, let's look at the actual mechanics. Creating a list is beautifully straightforward. You just use square brackets. You could have a list called numbers with 1, 2, 3, 4, 5, or a list called fruits, holding apple, banana, and cherry. But here is where Python's developer freedom really shines. Python lists are incredibly flexible. You can store numbers, strings, booleans, or even mix them all together in the exact same list. It's totally fine to have a list with the number 1, the string hello, and the boolean true. Once your data is in a list, you obviously need a way to access it. Each item has a specific position, which we call an index. Now, here is the absolute most crucial rule to remember for Python. We start counting from 0. So, in a list of fruits, apple is at index 0, banana is at index 1, and cherry is at index 2. But Python also gives us a brilliant superpower, negative indexing. If you want to grab the very last item in a massively long list, you just ask for index -1. -1 instantly gives you cherry. -2 gives you the second to last item, and so on. It is an incredible time saver. Number 3, modifying lists and methods. So we know how to create them. Now we need to talk about how to manipulate our data. Lists are mutable, which is just a fancy word meaning they can be changed after they're created. Take a look at how elegantly Python handles updates here. We have a list X containing 0 and 1. We set I to 0. Then, in just a single line, I, X bracket I equals 1, 2, Python updates the variable I and immediately uses it to assign the value 2 to the list at index 0. This perfectly illustrates mutability. You target specific spots and swap out values on the fly, without needing to rebuild the whole container. Beyond just swapping values out, Python gives us a robust toolkit of built-in methods to manage lists. 3 of the most common ones you're going to use every single day are append, remove, and len. Want to add a new item to the end, like adding orange to our fruit list? Just call append. Need to delete a specific item like banana? You use remove. And if you ever need to know exactly how many items are currently sitting in your container, just wrap your list in the len function, and it instantly returns the total length.
Number 4, the power of tuples.
But what if you don't want your data to change, ever?
Enter the plot twist, the tuple. Anchored right in the Python reference manual, a tuple is defined as an immutable sequence of arbitrary Python objects. Notice the key word there, immutable. Once a tuple is created, its values are completely locked in. They are unchangeable. And structurally, instead of the square brackets we use for lists, tuples are typically created using smooth parentheses.
So the crucial point we really need to understand is the structural and philosophical difference between these two. Lists are mutable. Their values can change, grow, and shrink, and they use square brackets. Tuples, on the other hand, are immutable. Their values are permanently locked and unchangeable, and they use parentheses. If you try to reassign a value at a specific index in a tuple, there's absolutely no way Python lets that slide. It's going to throw an error. When we compare the trade-offs side by side, lists use brackets and are changeable. But because Python has to manage all that flexible memory in the background, they are slightly slower. Tuples use parentheses and are permanently locked, which allows Python to process them much faster. You'll want to use lists for dynamic collections, like a user shopping cart, but you use tuples for fixed data, like the exact coordinates of a city on a map, or RGB color values. Using the right one makes your code safer and way more optimized.
Number 5. Real-world applications.
Let's actually put this into practice and bridge the gap between abstract concepts and real coding. Imagine we're building a student grading system. Step 1. You initialize a list called marks containing scores like 85, 90, 78, 92, and 88, all inside square brackets. Step 2. You can instantly calculate the total class score by wrapping that list in Python's built-in sum function. Step 3. You find the class average by taking that sum and dividing it by the len of the marks list. In just 3 lines of highly readable code, you've processed a sequence of data flawlessly. And I really want to emphasize why this matters so much. Lists and tuples are not just beginner concepts you learn and forget. They are literally the fundamental backbone of modern technology. Whether you're building mobile apps, structuring data for cutting-edge AI models, managing vast databases, or developing scalable websites, you are relying on Python's sequence containers. Knowing how to index, append, and choose between mutable lists and immutable tuples is a core skill you're going to rely on for your entire programming career.
Number 6, recap and mini challenge.
We have covered a tremendous amount of ground today, so let's do a rapid-fire recap. First, lists act as single unified containers for multiple values, freeing us from messy variable clutter. Second, Python uses zero-based indexing to count and incredibly powerful negative indexing to grab items from the back. Third, lists use square brackets and are mutable, meaning they can be modified with tools like append and remove. And finally, tuples use parentheses and are immutable, making them faster and perfectly safe for data that should never ever change.
All right, now it's your turn to get your hands dirty. Here is your mini challenge for this module. Open up your IDEs and try this out. First, create a list of your 5 absolute favorite movies. Second, use indexing to print out just the first and the last movie from that list. Third, use the append method to add a brand new movie to your favorites. And finally, create a tuple of 3 cities you'd love to visit. Actually, type it out and experiment with the syntax.
As you tackle that challenge, I want to leave you with a provocative thought to chew on. In our next module, we're going to explore dictionaries and sets, which map data to specific keys rather than just numerical indexes. So how might you combine the sequential power of lists with the mapping power of dictionaries to build an even more robust database for an AI system? Think about that. Keep coding, keep experimenting, and I'll see you in the next module of this explainer.